Hi, I'm looking at this question here, which is looking at investigating the queue at a bank where the inter-arrival time is 2 minutes and the service time is 3 minutes. We only have one clerk, so this is queues where there's only one service point. The first part of our question asks for us to show the queuing and service time of customers in a table from 9 until 9:15. So the first 15 minutes of the service of this queue. So our table is going to consist of several things. It's going to, of course, have the time. It's going to have the customer being served. It's going to have the arrivals, so the people that are arriving in my queue. The actual queue, so customers in queue. And lastly, the length of the queue. So we can actually just see visually as well as with numerically the length of that queue. Okay, so this is the columns usually used when doing analysis on queues. The time, the customer currently being served, the arrivals, if any, the customers that are in the queue, and how long the queue is. Okay, and we're going to start at 9 o'clock and work our way in 1 minute intervals all the way to 9:15. So I'll just fill in all the times. Okay, so once you've filled in all the times that are required, so I've gone from 9 o'clock to 9:15 in 1 minute intervals, we can now have a look at actually what happens. I'm going to assume at time 0 when we start, customer A has turned up, so we're not going to have any arrivals, we're going to have nobody in our queue. So this is time 0. Then after my first minute, customer A is still going to be served because he's going to take 3 minutes to be served. That's what the service time is. That's how long it takes to serve each customer. So customer A is still going to be in the queue. We're only in the first minute, so we're not going to have any arrivals, and so we're still going to have a queue length of 0. We now get to our second minute, and we have an inter-arrival time of 2 minutes. That means every 2 minutes a new customer turns up. So in our second minute, customer A is still being served because it takes 3 minutes to serve him. But now we're going to have customer B arrive. So we've got customer B in our queue, which means that I've now got a queue length of 1. Go into our third minute. So now customer A's had 3 whole minutes of being served. So now customer A is finished. We can now serve customer B. We are going to have no arrivals because we haven't reached our second minute yet. So we're going to have nobody in our queue. Then move on to our next minute. So customer B is still being served, but now we're going to have our next customer come in, so we'll have customer C. So we've got C in our queue, which means that our queue is 1 long. Moving on to our next minute, B has only been served for 2 minutes, put him on for his third minute. We're not going to have any new arrivals, but that means we've still got customer C in my queue, which means my queue is still 1 long. And now in our next minute, we're going to have B is now finished, so C is now going to be served, but customer D is going to turn up. So now we have D in our queue, which means we have a queue length of 1 still, hasn't changed. Following that on to the next minute, C still being served, we don't have anybody turn up, means we still have D in our queue still has a length of 1. Next minute again, we have customer C still being served. Next customer turns up though, so now we're going to have customer E turn up. So now in our queue, we have customer D and customer E, which means we now have 2 people in our queue. Next minute though, C's finished, so we can now take D out of our queue and start serving customer D. We don't have anybody arriving though, which means that we're left with just E in our queue, so our queue length drops back down to 1. If we then go to our next minute, customer D still being served, we now have our next customer arrive, so we have customer F, arriving, which means that in our queue we have customer E and customer F, which means we're back up to a queue length of 2. Next minute, customer D is being served, but we don't have anybody turning up, so we have customer E, customer F in our queue still, and we're back, and we still have a queue length of 2. In our next minute, D finishes, so we can now start serving customer E, but we now have another customer turn up, so we're going to have customer G turn up, which means that we have customer F and customer G in our queue, meaning we still have a queue of 2 minutes. Next minute, E still being served, but nobody's turning up, so we have customer F and customer G in our queue. Still a queue length of 2 minutes. Our next minute, we are still serving customer E, but we've got a new customer coming in, so now we are going to have customer H come in, which means that in our queue we have customer F, customer G, and customer H, which means our queue is now up to 3 minutes. But on our last minute for our analysis, we have customer E's finished being served, so we can now start serving customer F. Nobody's arrived, but we still have customer G and customer H in our queue, which means that our queue is temporarily dropped down to length 2. But if you think about it, our queue is going to keep getting longer, okay? It took a little bit. We went 0, 0, 1, 0, 1, 1, 1, 1, 1, but then we started getting a second customer, and that hung around for a bit, and then we started getting a third, and that's going to hang around a bit. So if you notice this pattern, our queue is slowly getting longer. And this is one of those things, our service time is 3 minutes, and our inter-arrival time is 2 minutes. If your service time is longer than your inter-arrival time, then you are going to be spending too much time serving customers, and your queue is going to be growing. Now let's try and answer the last of these questions. So the part B is, when is customer B finished? So that means it's finished being served. He's finished being at 9:06. That's that crossover between 9:05 and 9:06, because he finishes at the end of 9:05. He means he's done at 9:06. So customer B was finished being served at 9:06. How long does customer C wait in the queue? So customer C, he arrived here at 9:04, but he started getting served at 9:06. He was only in the queue here for 2 minutes. So customer C was only in there for 2 minutes. How long did it take in total for customer F to wait in the queue and be served? So we need to go and have a look at customer F. So customer F, he waited in the queue a total of 1, 2, 3, 4, 5 minutes. So he was in there for 5 minutes, and then he started being served. He's going to be served for 3 minutes, so that's going to make a total for customer F to be served for 8 minutes. So that is queuing with one service point, with an example of an inter-arrival time of 2 minutes, service time of 3 minutes, and some of the things that you can be asked. And as I've already mentioned, if you keep extending this table down, you're going to keep getting a longer and longer queue. So one of the things you need to know, service time must be less than inter-arrival time if the queue is not going to grow.